Hello, welcome all of you to my YouTube channel Connect to Physics. So in today's topic we are going to discuss about Poisson's ratio. So this Poisson's ratio which plays a very important role in elastic properties of material. So before to discuss about that, I'll first write down the title. So today's topic is Poisson's ratio. Okay. So now we are going to define this word. Exactly what you mean by Poisson's ratio means whenever a body is subjected to a stress. For example, here I have a body. Okay, when I am going to apply the stress to this body, okay, so here I am applying the pushing force. Think that here I am applying the pushing force from the two ends. When you are going to apply a pushing force to a substance within elastic limit, you can see that there will be a change in its dimension. It will get like this. That means the length of the body is going to decrease, as well as another part, that is diameter, is going to increase. So that's why we can define Poisson's ratio means whenever a body is subjected to a stress in a particular direction, we can see that there will be a change in a dimension of body in other two perpendicular direction. That is called as Poisson's ratio. Okay, one more time I'll repeat. Whenever a body is subjected to a stress in a particular direction, we can see that there will be a change in dimension of a body in other two perpendicular direction. That is called as Poisson's ratio. So Poisson's ratio is denoted as sigma. Okay, we can denote Poisson's ratio with the word sigma. So here in this Poisson's ratio, we are going to learn about two important factors. The first important factor is linear strain. Okay, now we'll discuss that. The first one is linear strain. So linear strain means, think that here I have a body, or else you can call it as a wire. Okay, so when I am going to apply the pulling force, okay, here I am applying the pulling force to this body. When you are going to pull this body, now we can see that there will be a changes in its length as well as diameter. Two factors are going to change. Now first we are going to talk how the length is going to change. See, the original length of body is L. When you are going to pull this wire, the length of this body is going to change. Clear? Original length is L. When it is going to extend its length, that is called as delta L. So as we know that strain is nothing but, the concept is linear strain. Strain is nothing but change in dimension. Original length compared to its change in length. Clear? As we know that the formula for the strain is change upon length divided by to its original length is called as strain. So here what happened, the length of this body is going to increase from L to delta L. So this phenomena is called as linear strain. Okay, now I will write the equation for linear strain. You can divide with alpha. Okay, so alpha is equal to change in length divided by original length. Clear? So change in length is called as delta L divided by original length is L. So after substituting this, alpha is equal to delta L by L. This is equation number 1. Clear? Linear strain means whenever a body is going to change its length, that phenomena is called as linear strain. This is the first concept. And second concept is second concept is lateral strain. Okay, so lateral strain means, so in the earlier case, what happened? We have applied a pulling force. That's why the length of the body is going to change. Clear? Now another factor here, you see the diameter. Original, that's diameter, I'm going to call it as D. When the diameter, when you're going to apply the pulling force to a wire, its diameter is going to change. See, this is the original diameter. Now when you're going to apply the force, the diameter is going to decrease. That is, I'm call it as an delta D. Clear? Or else अगर आप pushing force लगा दिए तो क्या हो जाता है यहाँ पे? When you are going to push this one, diameter will get changed. It will come in positive sign. So that's why for lateral strain, we can define that whenever a body is subjected to a stress, there will be a change in its diameter. That is called as lateral strain. So this lateral strain is denoted by this beta. Linear strain is alpha and this one is beta. So I can write that beta is equal to change in diameter divided by to its original diameter. Okay, so beta is equal to delta D by D. This is equation number 2. Okay, next we know that Poisson's ratio is equal to linear strain by lateral strain. Okay, so Poisson's ratio का जो सिंबल था that is sigma equal to linear strain क्या है हमारे पास, change in length to its original length divided by lateral strain क्या है, diameter का change in diameter to its original diameter. तो अगर इसको इक्वेशन के फॉर्म में लिखेंगे आप तो सिग्मा इज इक्वल टू डेल्टा एल बाई एल डिवाइडेड बाई डेल्टा डी बाई स्मॉल डी. दिस इज इक्वेशन नंबर 3. Clear? Now we have to be substitute all these value equation 1, 9, 2 and 3. So we will get clear. So after that, so where we know that where alpha is equal to dl by delta l by l and beta is equal to delta d by d. Okay, so Poisson's ratio is equal to Poisson's ratio, that is equal to जो सिग्मा है Poisson's ratio का सिग्मा is equal to alpha divided by beta. This is called as Poisson's ratio. So here within elastic limit, linear strain is proportional to lateral strain. That is called as Poisson's ratio. I hope all of you have understand the concept. If you like my video, please share and subscribe. Thank you for watching my channel.